So hello everyone. In today's video, we are going to see what are the properties of modulus. Okay, what is the properties of modulus in complex number? To understand this, we will take two complex number. Let's suppose z1 is a complex number and z2 is a complex number. Says that z1, z2 both belongs to z. Means z1 and z2 are complex number. And let the z1 be x1 plus iota y1 and z2 be x2 plus iota y2. Got it? So here we'll see the first property of modulus. The first property of modulus is the modulus of any complex number is always greater than equal to 0. The modulus of any complex number is greater than equal to 0, means it's positive. What is modulus of a complex number z? Modulus of complex number z is under root of x square plus y square. Got it? So the value of this under root can't be negative. So this mod of z will always be positive. Now next, the next property of modulus of complex number is that the modulus of complex number will be greater than the real part, the mod of real part of z, and the modulus of z is also greater than the imaginary part of z. It's also greater than the imaginary part of z. Why? Because what is the mod of z? The mod of z is under root of x square plus y square. And what is real part of z? Real part of z is x. So obviously it will be greater than x. What is modulus of z? Modulus of z is under root x square plus y square. Obviously this is greater than the imaginary part of z. What is imaginary part of z? Y. Got it? So this one is my second property of modulus of complex number. Now third property is if two complex number are in multiplication, z1 multiplied by z2, and we have to calculate the mod of the resultant complex number which we will get after multiplying z1 and z2. So that will be equal to the modulus of z1 multiplied by modulus of z2. Means this mod we can distribute over z1 and z2. Got it? What is the fourth property? The fourth property of complex number is the modulus we can distribute over the division also. If z1 is a complex number divided by z2, we want to find the modulus of whole. This will be equal to z1 modulus divided by z2 modulus. Got it? Now fifth property is, suppose z is a complex number. They said z to the power n. Z to the power n means they can ask z to the power 50. Z is a complex number, right? And z raised to the power 50. What is the modulus of z raised to the power 50? Complex number. Means modulus of this complex number, it will be equal to, you can find the modulus of z first, then you can raise it to power n. Got it? See, in these three properties, we have seen that mod we can distribute over z1 and z2. But in the case of addition and subtraction, if they have written z1 plus z2 mod, this we can't write equal to z1 mod plus z2 mod. This mod we can't distribute. This mod we can't distribute over addition or subtraction. z1 minus z2. We can't write equal to z1 minus z2 individual. z1 mod minus z2 mod. This we can do in the case of only multiplication, division, or in case of powers. But in case of addition and subtraction, we can't distribute this mod like this. This is wrong. Okay. So next, property 6 of modulus of complex number. It says that 2 times of modulus of z1 square plus modulus of z2 square is equals to modulus of z1 plus z2 square plus modulus of z1 minus z2 square. Got it? If we will prove this one, we can prove this one using vectors. Earlier we have seen that what is a complex number? A complex number is nothing but a position of a point in the complex plane. Suppose z1 is a complex number somewhere here. So z1 represents this point. in the complex plane. Z2 represents this point in the complex plane. So now if we will draw, now if we will join the origin from the complex number z1, we will get the position vector z1. If we'll draw the, if we'll join the origin with the complex number z2, we'll get one more position vector z2. Now if they are position vector, we can move the vectors, right? So z2 we can move and we can make here z2. This is my z2 vector. Now the z1 vector also I can move, so we will get a, this is my z1 vector. This is my z1 vector. Now we got a parallelogram, right? So what is z1 plus z2? Z1 plus z2 is the diagonal of this parallelogram, right? Z1 plus z2 is the diagonal of this parallelogram. This line represents z1 plus z2. Got it? Now what is z1 minus z2? Z1 minus z2 represents the another diagonal. Z1 minus z2 represents the another diagonal. This diagonal is z1 minus z2. So this white one is z1 plus z2, and this blue one is z1 minus z2. Got it? This vector is z1, this vector is z2, so this white one is z1 plus z2. If this is z1, this one is z2, so this vector will be z1 minus z2. Got it? Now there is one property in the parallelogram, that if suppose this is a parallelogram with the side lengths a, b, b, and the diagonal is d1 and this diagonal is d2. So what is the property of parallelogram? The property of parallelogram says that sum of squares of sides, sum of squares of side lengths is equals to sum of squares of diagonal. Means a square plus a square, right? Side length is a, this side length is a, this side length is b, this side length is b, plus b square plus b square is equals to d1 square plus d2 square, diagonal squares, right? So from here we'll get 2a square plus b square is equals to d1 square plus d2 square. This is a property of a parallelogram. So this property we will use in this parallelogram. So tell me, what is this side length? What is this side length? This side length is mod of z1. Here a value is mod of z1. So this side length is mod of z1 square. What is this side length? This side length is also mod of z1. So mod of z1 square. This side length is z2. So this is modulus of z2 square, plus this side length is again z2, modulus of z2 square is equals to, what is d1 and d2? The diagonal is z1 plus z2 and z1 minus z2. So modulus of z1 plus z2 square plus z1 minus z2 square. Got it? Now if we will simplify this one, here we'll get 2 times z1 square, modulus of z1 square plus modulus of z2 square is equals to z1 plus z2 whole square plus z1 minus z2 whole square. So we have seen, if we will consider the complex number as vectors, it is very easy to prove all the properties of complex numbers. So this we got. Understood? And next there is one more method by which we can prove this one. So now we'll do the proof by method 2. We can use one more method, right, to prove this property. We can start from right hand side. What they've given in right hand side? Right hand side they gave z1 plus z2 whole square plus z1 minus z2 whole square. Now we can expand this one. Actually, modulus of z1 plus z2 whole square is modulus of z1 plus modulus of z2 square plus 2 z1 into z2. Similarly, this also we can expand. This we will get modulus of z1 square plus modulus of z2 square minus 2 modulus of z1 into modulus of z2. So we can see that this term and this term will get cancelled, and here we will get 2 times modulus of z1 square plus modulus of z2 square, which will be my left hand side. So like this also we can prove. But this proof, if you will understand, this will help in solving questions. This approach will help in solving a lot of questions if you will assume the complex number as vectors. Got it? Now next. The next and the this was property 6. Now property 7. Property 7 of a complex number says that modulus of z1 minus modulus of z2, and here we'll take absolute value function, is always smaller than or equal to z1 plus z2 modulus. Is smaller than or equal to z1 modulus of z1 plus modulus of z2. So this we can prove. This property we can prove again by using vectors. This you can say this is nothing but triangle inequality. Triangle inequality. Well, inequality. We have seen when we will draw a triangle. Suppose this is a triangle. This side length is A, this side length is B, this side length is C. So the sum of two sides, A plus B, is always greater than the third side. The third side, which is C. Got it? And the difference of two sides is always less than the third side. Got it? These two are the triangle inequalities. So using this also, this only we can prove this property. So we'll start the proof. Again, we'll prove by vectors only. So we'll see the proof of this property. Draw the position vector of z1. Suppose z1 is here. z2 coordinate is here. So where is how we'll draw position vector of z1? Position vector of z1 will be, we'll get after joining origin with z1. Again, origin only will join with z2. Now z2 we can shift, we can move the vector, so z2 will move and will bring here. This will be my z2. Now if we will add both of them, we will get the third side of the triangle. We'll get the third side of the triangle. This will be my third side of the triangle, and this will be equal to, this is equals to z1 plus z2. Got it? Look at this triangle. What is this side length? This side length is equals to mod of z1. What is this side length? This side length is equals to mod of z2, and this third side length is modulus of z1 plus z2. Got it? So from triangle inequality we can say that the sum of two sides of the triangle, modulus of z1 and modulus of z2, means sum of this side and this side is always greater than the third side, z1 plus z2. So this got proved by using triangle inequality, this part. And now we'll see this part. What is this? They have written here modulus of z1 minus modulus of z2, means this side minus this side. This side minus this side means difference of two sides. Difference of two sides will be less than or equal to the third side. Third side is modulus of z1 plus z2. So by triangle inequality, easily we can prove these two properties. Now, listen, this modulus represents the modulus function. Modulus of complex number z1. Similarly, this represents the modulus of complex number z2. This represents modulus of complex number z1 plus z2. but this this mod is actually the absolute value function, which we studied in algebra. Absolute value function. This outer mod is absolute value function. Got it? So always try to solve the complex number problems by assuming them as vectors. Got it? So easily you can prove the properties. Some question, it is very easy if you will assume them as vectors. Easily you can solve some questions. Got it? Very easy. Thank you.